Hello, good afternoon. Okay, I have received some report about the lab marking for lab 3. Some of the students didn't have the marking for the lab 3 yet. So I think it's the system error. I will have a check of it after the tutorial. And then, yep, don't worry about it. If you get a question mark on your result, just don't worry about it. I will have a check of it today and update it. You should be able to get the result by tomorrow. And let's have a look of the first thing for the lab 5. So this week is about the congestion for TCP. So that's just a quick review for this part. This one is, I think it's a question on the final exam 1 year ago. So can you try to answer the question? So what is this thing? If we open the lecture slides, then we can find out the answer here. So can someone name the event 1? I got one answer. Okay. Yeah, please number 1. Yeah, you're right. It's multiple X. So how do you call this one? When you receive more than 3 consecutive acknowledgement for this same acknowledgement number, how can you call this one? Yes, fast retransmission. So that's one of the timeout event, congestion event. This is not timeout. And what's next? What's the second one? This one. Yeah, this one is the timeout. So you can see it's different. For the congestion event 1, we only come back to here. For the congestion event 2, we come back to 1. So that's the difference. And you should know this one is Reno or Tahoe. Reno or Tahoe. Yeah, it's a Reno here. And what's the name of 3 in this part? And what's the name of 4 in this part? So how do you call the phase 3 and phase 4? They have a name for that. So you can see that the 3 is a curve, but the 4 is a straight line. Yeah, don't worry if you don't remember. Let's go to the lecture slides. Then you can easily find out the answer. So we only care about these two, TCP Tahoe and TCP Reno. The TCP Tahoe, the rule is like this. We will reset the congestion window size to 1 if we have any kind of congestion event, including the fast retransmit and the timeout. But for the Reno, it's a bit wise compared to the Tahoe. You can see on the timeout, we go back to 1 because the timeout is like serious than the fast retransmit. So on the fast retransmit, we only cut out the congestion window by half. But do you think Tahoe is better than Reno or Reno is better than Tahoe? Any idea? So which one is better? So in here you can say Reno is better, right? In this part because it has more condition in this part, but you cannot say Reno is always better than Tahoe. But you can say generally the Reno is better, but sometimes the Tahoe is better. So it depends on the traffic on the internet. So it depends on your condition of your internet connection. For example, your connection is really, really bad. You are connecting to internet which is pretty bad. The signal is unstable. You're frequently disconnected. In this case, actually the Tahoe is better. So you can see the Tahoe is better for the worse environment, but Reno is better suitable for the faster and stable internet connection. Yes, then we can scroll up a little bit. Then you can figure out which is 3 and which is 4 by looking at this part, slow start and AIMD. Yes, so you can see the slow start is the phase 3 and the AIMD is phase 4. Yes. So by looking at this graph, you should be able to name what is this and what is that and what will happen if this happen, if number 1 happen or happen. So you should be able to know that. Otherwise, you cannot do the calculation for that. And I remember one of the question in the final exam is that what happened after this part, after numbers 2? I think it's the same question here. So what happened after number 2 here? So obviously go back to 1 here, but before we go back to 1, before we reset the congestion window to 1, did we do any kind of calculation during this process? Yeah, this is timeout. Okay, so you can see before we go to the reset to 1, then I think it's here. Event timeout. You can see once we have the event timeout, then we will set the threshold for congestion window to the current value divided by 2, and then we reset the window to 1, which means we will have a mark on this part. We will mark the value in here, actually it's in here, right, as the threshold value. So why do we need to use this value? Because of this, right? So you can see we change from the slow start to AIMD at this point. So that's the thing happen. We firstly calculate the threshold for slow start, and then we reset to 1, then we start the slow start. And once we reach the threshold value, we switch to AIMD and keep going until we reach another congestion event. So just go through the slides, then you should be able to know it. Okay, so in here, we come to the exercise 1. So this one is pretty easy. You can just simply download this file, and then you don't need to worry about the code inside. You just need to run it. And then it will have some output like this. Then we just use the command in here. We firstly run the command, run the script. Then we use the second command to generate a graph. So can you try to do it right now? And I will show you the example output. So just download this one and try to run it. You can scroll up. You can see the script that we need is in here. Okay, let me try to run it right now. So let's see. So firstly, we need to have this script, tp window.tcl. You can also have a check. What do we have inside? You can just simply cat tp. You can see it's just a script running on the NS2. So you can try to learn it because at the end of it, we need to write our own script. You can see, or maybe next one. This time we don't need to modify it, isn't it? We just need to have a look of it. But in the next lab, maybe we need to write something about it. So currently you don't need to worry a lot about it. So try to learn it, how to set up a node and how to link them and make them have some connection, and how to set the packet size and how do you send it, and how do you ask them to stop and start the FTP connection and TCP connection. And at the end, how can you like run them? So it will not be very hard, don't worry about it. Next lab, we will talk about how to write it. But for now, I don't think you need to write it. So let's try to learn how to run it at first. So for example, we already have this one. So the task we need to do is just simply copy this command and run it. So you can see I clear everything and I run the ls command to make sure I do have the stuff in the current folder. Then I just copy and paste the command. Just copy this one and paste. Yep. Then you can see not there is no output. But if you check the folder, or you can run the ls command again, then you can see we generated some outputs in here. So we can run the next one, the GNU plot. So just paste. Then you can see here are the outputs. So based on your observation, what happening here at this point? Oh, sorry. Just like the last one, right? Just like the last question. This point must have a congestion event. Could be a timeout or could be a fast retransmit, because this one is a table. So you can figure out the value, what's the value for that, and what happened to that. Then you can answer the question by yourself. And number 2, we need to run this script, window tput.plot. So make sure you do have the script in here. Then you run it. You can see we have another output here. So use this graph and answer the question. So you can see we are using the table as our algorithm, congestion control algorithm. And this is our average throughput. It can maintain a stable speed at the end of it. Okay, so next part, after you answer the question 3, we come to the question 4 at this part. You need to repeat the step in question 1 and 2. But before you do that, you need to change the script inside. So you need to open the window.tcl and change this part. So let's do it. So we need to go to the script. Sorry, no, this one. This one. We need to close it and clear everything. In this time, we need to modify the file of window, maybe not tp window, tp window.tcl. We need to modify this script. Then we need to find the line have this content. So we just copy it. Yeah. So we just search this line. Maybe TCP. Yeah. So this is the line we are looking for. So we need to change it to new agent TCP Reno. So because this one is Tahoe, we are changing it to Reno, just like this. And you can have a double check if we type it wrong or not. It should be correct. Then we save it and we just run it again. So just come back to the question 1 here. You can see how to run it. Let's scroll down a little bit. This is how we run it. Just run it again, and then we plot it again. So let's see what happened. So can you see the difference? So last time when we have a timeout event, it will go back to 1, right? But this time it only cut out by half because this is Reno. So you can answer the question in the report right now. You can say, because we are currently using Reno, so that's the reason why the graph is different. And then we can have a look of the question 2 again. And you can compare with the first graph of the table if the throughput improved or not. I think the answer is yes, but you need to show it in the report. You can say what's the difference between these two methods, these two algorithms. But as you can see here, in this exercise, it's pretty easy. Just run the script and generate the plot and put it into your report and answer the question. And in the question 4, you just repeat it with different algorithm. And just go back to question 3. I didn't mention it here. You need to change the value for it, right? So in the question 1, we put the value as 100. So in the question 3, you need to change the parameters. So find the value of the maximum congestion window at which TCP stops oscillating. So what happened here? We need to change the value in the parameters. Do you know how to change it? So in the question, it says we don't need to change the RTT. So don't need to touch this part, but this one. So let's try to change to another value and see what's the output for that. Okay, so come back to here. And I think we need to, maybe I don't. Before you do that, make sure you are running in the table, but here I am running with the Reno. So be aware of that. Our output is different. Okay, so just run this command, but change the value to, in here I just put 50. And then we generate this one, the window. You can see the graph is like this, which satisfy the requirement in the question 3. It's not shaking here because we don't have any kind of congestion event. And how about we run it again? Let's set to 70 and then generate the file again. You can see when we change the value from 50 to 70, it will start to shake again. So we need to figure out what's the maximum value for that. Maybe between 50 and 70, you need to find out the size by yourself. So what is the maximum value that the graph is still looking like this, So just try them one by one. So what you need to do is just keep changing this number. Let's say 65 or 660, and then plot it again and see if it's good or not. But remember, this one is Reno, it's not Tahoe, so your output could be different as this one. So before you do that, make sure you are running on the Tahoe by changing the TP window.ttl. So make sure the line here is not Reno, so it's not Reno. We need to delete it and save it and do it again. Do it by yourself, but this one is pretty easy, right? Just need to figure out what is the maximum parameters in here. And that's the exercise 1. And let's do the exercise 2 right now. You need to download the script. So there are 4 scripts. 1, 2, 3, 4. Just copy and paste into the folder. What's next? Pretty easy, right? Just copy and paste, and run it. You can see we have done it, and we have some new file generated. Then we just come to the second part, the plot, and copy and paste. Okay, so let's see what do we have in here. We have a generated file, the PNG file. So maybe put it into the Chrome, then you can see this is the output. So we can see we have 1, 2, 3, 4, 5 different flow, which means we have 5 different connection between our machines. And they are like competing with each other on the same network, just like this graph. So you can see the first flow is from 2 to 3. So it's from this one. From this one to here, and then to here, and then to here. And the second flow Where's the second flow? Second flow is 4 to 5. So it's 4 to 5 to here. And the third is 6 to 7 and 8 to 9. So you can see they are competing in the same connection from 1 to 0. So that's the reason they will like have the competition on the bandwidth. And here is the throughput of it. So you need to explain why they are they like acting like this. For example, the flow 2 to 3. Firstly, the speed is really quick. It's around 110 or something, 115, and it dropped down to like 15 here or 10 in here. So you need to figure out what happened here. You can see it's because the flow 4 to 5 and 6 to 7, 8 to 9 joined the competition. So this is the reason why the speed, the throughput dropped down so heavily. So just try to explain it. And if you can have a look of the script. So you can have a look of the TP fairness TCL. You can see, you can figure out the exactly time when they start. I think it's around this place. You can see when they start and when finished. Yeah, so they're different FTP connection because the FTP is using the TCP connection, and you can see a for loop in here, and they are starting one by one. So try to analyze how could this happen, but basically just the TCP fairness is pretty fair, right? They like both have the similar speed. But let's see what happened if the TCP competing with the UDP connection. So the same one, we need to just simply copy the command in here. Run this one, the TP UDP TCP link capacity. So open the terminal and paste. So in the link capacity, we need to change. So firstly, the command is wrong. We need to specify .tcl in here. If you copy this command, it will not run. So you can copy this one like this. Specify the bandwidth, and it will generate some new file, and you still need to plot it. And see if, and let's see if we can read it. So you can see when the TCP competing with the UDP, so which one is faster? So in here, obviously, the UDP is faster, but do you know what is the reason for that? Like UDP is way faster than TCP. So if they are both using the same computer and same internet and same connection, why do they have different speed by using different method to send out the packet? The destination is the same, and the internet connection is still the same. So why TCP is slower? Any idea? So why the TCP is slower here than the UDP? Even they have the same environment and the same connection. Mm. So that's the output. Let me take a screenshot and let's see. How about we change this value to a larger one? Let's say 1000 times larger. And then you can have a check. The TCP is still slower, right? So let's try 10,000 times larger. Yeah, still the same. So what happened? So no matter how large is the bandwidth, we still have this problem. So this is the original one. So this is because the congestion control algorithm. So no matter how large is the bandwidth, the TCP will still have the congestion event like fast retransmission or the timeout event happen. So that's the reason why the speed will drop sometimes. Because once we have a timeout event or fast retransmission event, we need to reduce the congestion window size, which means we will reduce our throughput. So in here, you can see it's oscillating here. And that's the reason why TCP is slower than UDP, because the UDP will increase the probability of timeout events for TCP connection. But UDP itself does not have any kind of congestion control algorithm. So UDP does not care about the timeout, but TCP does. So the reason of TCP cannot reach higher speed than UDP is it has the algorithm on the congestion control. Okay, so that's all the thing for the lab you need to do. And you can see there are some other questions inside here. So if you have any trouble with that, just let me know. But after you get the graph, it should be pretty easy for you to answer it. Okay, I will enable the screen sharing. If you want, you can share your screen. And yes, and I think it's pretty close to the due for our assignment, right? So if you have any trouble with it, just let me know. I will close the recording right now, so you can share your screen.